Assalamu alaikum wa rahmatullah. How are you, grade 3? Today we are continuing our lesson in math about patterns in multiplication chart. We have explained in the previous video the multiplication table and how we can read it. Now we are practicing and we are strengthening our knowledge in the multiplication table. Here in page 241, I want you to write today's date on the top of the page as usual, and we start the exercise number 1. Now let's read together. How are 3 times 7 and 6 times 7 related? How are they related? Please, I want you to pause the video and you answer by yourself, then you check your answers with me, alright? Very good. Now let's look at 6 times 7. 6 times 7 is the double of 3 times 7. How is that? Because in the distributive property, we took that 6 times 7, I can break it down into 3 times 7, ugly 3, excuse me for this, 3 times 7 plus 3 times 7. I can repeat the parentheses, or I can make times 2 directly. Okay, 3 times 7 equals 21 plus 3 times 7, another 21. So together they are 42. It's the same product as 6 times 7. Alright, great. Now, number 2, construct arguments. In the table on page 238, is the pattern that Yolanda found also true for factors that are multiplied by 3 and 6? Yes or no? What do you think? Let's go back to the table in the previous page. For 3 and 6, it's the same as 2 and 4? Yes, because 6 is the double of 3. So any product in the 6 times table is the double of the product in 3 times table if I multiplied by the same factor. Let's see this. We can write it, or we can explain it this way. 6 here, 6 times 2 equals 12. 6 is what? It is 3 and 3. Okay, so 3 times 2 plus 3 times 2 okay, 3 times 2 equals 6, and another 3 times 2 equals 6. It will give me 12 as a sum. Alright? Very good. Now let's move to number 3. What pattern do you see in the columns and rows that have 0 as a factor if we look at this table? I will look here. We agreed that all the unshaded numbers, they are products. Okay? Now let's move to this 0 as a factor. 0 times 0 equals 0. 0 times 1 equals 0 too. 0 times 2 equals 0. So when 0 is involved in a multiplication equation, the product is always 0. So I can see 0 in the rows and zeros in the columns. Okay, now explain why is that? Why is this true? Because we knew that in the zero property that any number multiplied by 0 is 0, and as you all know that 0 is a hero. 0, it's a zero property. It's a zero property. That means that any number multiplied by 0 equals 0. Okay, very good. Now, number 5. Look at the shaded products. What pattern do you see? Okay, let's see our observations here. 0, 8, 14, 18, 20. Then 20, 18, 14, 8, 0. So what can I say? I can say that each product appears twice. 0 here appears once and there appears twice. 8 here, 8 there. 14 here, 14 there. Alright, so each product appears twice. Second, the same products read from 0 to 20. The same product read from 0 to 20. I can here read 0, 8, 14, 20, 18, 20. Then it goes back to the same numbers. Number 6, write the equation for each shaded product. Write the equation for each shaded product. Okay, I need to write products here. 9 times 0 equals 0. Okay, can I use this note? Let's see. Okay, 9. I will use this as my times. Okay, 9 times 0 equals 0. Then 8 times 1 equals 8. Then 7 times 2 equals 14. Then 6 times 3 equals 18. Then 5 times 4 equals 20. Okay, this is for the pattern that goes from down to up here. Okay, then back here. 4 times 5 equals 80. Now I am back. Using this. Four times 5 equals 20. Then 3 times 6 equals 18. Look, and I want you to complete this. Okay. What are you going to notice? What are you going to notice? That the factors here, 5 and 4, when I change their places or their positions, they give me the same product, which is very clear for the property associative property. The associative property that if I change the places of the factors, the product will remain the same. Alright, now number 7. Look at the factors you wrote. Explain why the pattern for the products is true. Because changing the orders of the factors, as we said, doesn't change the product. Changing the orders of the factors doesn't change the product. Okay, now I want you to practice by yourself. Shade the line in the multiplication table to show how this pattern is true for other products. The products are repeating. They are appearing twice too. 0, 4, 6, then 6, 4, 0. Very good. Now let's move to the next page. Now, number 9. How many arms do 9 starfish have if each starfish has 6 arms? If each starfish has 6 arms, write a multiplication equation to solve. This is very easy. I will not answer it. You will answer it by yourself. And number B also, it's easy. We'll move to number 10. Karen found a pattern on the multiplication table. Good job, Karen. What pattern did she find? Explain why it is true. Now they have highlighted numbers 6, 12, 18, and 24. And in the row of 6, they have highlighted 6, 12, 18, and 24. What do you see? We can see that every multiple of 6 is a multiple of 3. 6 is a multiple of 6. 12 is a multiple of 6. I can see that also 12 and 18 and 24, they are all multiples of 3. Number 11, it's very easy. It's an estimation. You may not say the exact number, but you can estimate the number without making any calculations. Alright, now let's move to number 12. Describe a pattern you see in the 9th row of the multiplication table. Describe a pattern you see in the 9th row of the multiplication table. We can use this multiplication table and we can look to the rows, to the 9th row. Okay, and you tell me what pattern do you see? The 9th row. What pattern do you see? It's very obvious that the patterns here, 0, 9, 18, 27, 36. What do you know about even and odd numbers? How these numbers are moving forward? Yes, exactly. 0 is an even, then 9 is an odd. Even, odd, even, odd. So they are moving from even to odd numbers. So this is the first observation of the 9th row. And as we have studied before, that the sum of the 2 digits in the product of 9 as a factor, we can see that the digits, the sum of digits is always equals to 9, other than multiplying by 0, of course. 9, it's 9. 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. So the sum of digits is always equals to 9. Very good. Number 13. You saw this multiplication table, and we want you to shade the first row and the first column on the multiplication table. Let's shade it. All right. Let's shade it. Number 1. Okay. Alright, what pattern do you see? What pattern do you see here? What we can see is that all products are equal to the other factor. All products are equal to the other factor. What do I mean by this? I mean that when I multiply 1 by 1, I will get 1. When I multiply 1 by 2, I will get 2. When I multiply 1 by 3, I will get 3. So all the products are equals to the second factor that I multiply with. All products are equals to the second factor I multiply by. For example, 1 times 2, it's equal to 1 or 2? It's equal to 2. 1 times 5, it's equal to 5 or 2? It's equals to 5. So the product of these equations having 1 as a factor is equal to the second factor exactly, and which is true about the identity property of number 1. This is the identity property, and as you know that 1 is a mirror. 1 is a mirror. Very good. For the part B, explain why the pattern is true, as we set up that it is for the identity property of number 1. That's all for today. Thank you very much. See you in the next video. Assalamu alaikum wa rahmatullah.